Chapter 5. The Creation of Thinking. Making Things to Think With. Bo Dahlbom and Lars Erik Hjalmert, in their forthcoming book, Computer Future, observe that just as you cannot do very much carpentry with your bare hands, there is not much thinking you can do with your bare brain. Every agent faces the task of making the best use of its environment. The environment contains a variety of goods and toxins, mixed in with a confusing host of more indirect clues, harbingers and distractors, stepping stones and pitfalls. These resources often amount to an embarrassment of riches in competition for the agent's attention. The agent's task of resource management and refinement is thus one in which time is a crucial dimension. Time spent in the futile pursuit of prey, or bracing oneself to withstand illusory threats, is time wasted, and time is precious. As we discussed in the last chapter, Gregorian creatures take in from the environment various designed entities and use them to improve the efficiency and accuracy of their hypothesis testing and decision-making. But there is something we haven't yet tackled. How much room is there in the brain for these artifacts, and how do they get installed? Is the brain of a Gregorian creature so much more capacious than the brains of other creatures? Our brains are modestly larger than the brains of our nearest relatives, although not larger than the brains of some dolphins and whales. But this is almost certainly not the source of our greater intelligence. The primary source, I want to suggest, is our habit of offloading as much as possible of our cognitive tasks into the environment itself, extruding our minds, that is, our mental projects and activities, into the surrounding world, where a host of peripheral devices we construct can store, process, and re-represent our meanings, streamlining, enhancing, and protecting the processes of transformation that are our thinking. This widespread practice of offloading releases us from the limitations of our animal brains. An agent faces its environment with its current existing repertoire of skills, perceptual and behavioral. If the environment is too complicated for these skills to cope, the agent is in trouble unless it can develop new skills or simplify its environment, or both. Most species rely on natural landmarks to find their way around, and some species have developed the trick of adding landmarks to the world for their subsequent use. Ants, for instance, lay down pheromone trails, odor trails, leading from nest to food and back. And the individuals in many territorial species mark the boundaries of their territories with idiosyncratic aromatic compounds in their urine. Posting your land in this way warns off trespassers, but it also provides a handy device you can use yourself. It saves you from needing some other way to remember the boundary of that part of the environment in which you have invested significant efforts of resource refinement or even cultivation. As you approach the boundary, you can smell it. You let the outside world store some easily transduced information about where the important joints in nature are, so that you can save your limited brain for other things. This is good stewardship. Putting deliberate marks on the environment to use in distinguishing what are for you its most important features is an excellent way of reducing the cognitive load on your perception and memory. It's a variation on and enhancement of evolution's good tactic of installing beacons where most needed. For us human beings, the benefits of labeling things in our environments are so obvious that we tend to overlook the rationale of labeling and the conditions under which it works. Why does anyone ever label anything, and what does it take to label something? Suppose you were searching through thousands of boxes of shoes looking for a house key that you thought was hidden in one of them. Unless you're an idiot or so frantic in your quest that you cannot pause to consider the wisest course, you will devise some handy scheme for getting the environment to assist you with your problem. You want, in particular, to avoid wasting time by looking more than once in each box. One way would be to move the boxes one at a time from one stack, the unexamined stack, to another, examined stack. Another way, potentially more energy efficient, is to put a check mark on each box as you examine it, and then adopt the rule of never looking into a box with a check mark on it. A check mark makes the world simpler by giving you a simple perceptual task in place of a more difficult, perhaps impossible, memory and recognition task. Notice that if the boxes are all lined up in a row and you don't have to worry about unnoticed reorderings of the queue, you don't need to put check marks on them. You can just work your way from left to right, using the simple distinguisher that nature has already provided you with, the left-right distinction. Now let's concentrate on the check mark itself. Will anything do as a check mark? Clearly not. I'll put a faint smudge somewhere on each box as I examine it. I'll bump the corner of each box as I examine it. Not good choices, since the likelihood is too high that something else may already have inadvertently put such a mark on a box. You need something distinctive, something that you can be confident is the result of your labeling act, and not some extraneously produced blemish. It should also be memorable, of course, so that you won't be beset by confusions about whether or not some salient label you encounter is a label you put there, and if so, what policy you meant to follow when you adopted it. There's no use tying a string around your finger as a reminder if, when it later catches your eye, thereby fulfilling its function as a self-control beacon offloaded into the environment, you can't remember why you tied it. Such simple, deliberate marks on the world are the most primitive precursors of writing, a step toward the creation of the external world of dedicated peripheral information storage systems. Notice that this innovation does not depend on there being a systematic language in which such labels are composed. Any old system will do as long as it can be remembered during use. Popperian creatures, and their subvariety, the Gregorian creatures, live in an environment that can be roughly divided into two parts, the external and the internal. The denizens of the internal environment are distinguished not so much by which side of the skin they are found on. As B.F. Skinner once remarked, the skin is not that important as a boundary, as by whether they're portable, and hence always available, and hence relatively more controllable and better known, and hence more likely to be well designed for an agent's benefit. The external environment changes in many hard-to-track ways, and is in the main geographically outside the creature. A Popperian creature's portable knowledge about the world has to include some modicum of knowledge about the omnipresent part of its world that is itself. It has to know which limbs are its own, of course, and which mouth to feed, but it also has to know its way around in its own brain to some extent. And how does it do that? By using the same old methods, by placing landmarks and labels wherever they would come in handy. Among the resources to be managed under time pressure by an agent are the resources of its own nervous system. This self-knowledge need not itself be represented explicitly, any more than the wisdom of an unthinking creature needs to be represented explicitly. It can be mere embedded know-how. But it is crucial know-how about how to manipulate that curiously docile and relatively unfleeting part of the world that is oneself. You want these refinements of your internal resources to simplify your life, so that you can do more things better and do them faster. Time is always precious with your available repertoire of talents. Once again, there is no use creating an internal symbol as a tool to use in self-control if when it catches your mind's eye you can't remember why you created it. The manipulability of any system of pointers, landmarks, labels, symbols, and other reminders depends on the underlying robustness of your native talents at tracking and re-identification, providing you with redundant, multimodal paths of accessibility to your tools. The resource management techniques you are born with make no distinction between interior and exterior things. In Gregorian creatures such as us, the representations of features and things in the external or internal world become objects in their own right, things to be manipulated, tracked, moved, hoarded, lined up, studied, turned upside down, and otherwise adjusted and exploited. In her 1977 book, On Photography, the literary critic Susan Sontag points out that the advent of high-speed still photography was a revolutionary technological advance for science because it permitted human beings, for the first time ever, to examine complicated temporal phenomena not in real time, but in their own good time, in leisurely, methodical, backtracking analysis of the traces they'd created of those complicated events. As noted in Chapter 3, our natural minds are equipped to deal with changes that occur only at particular paces. Events that happen faster or slower are simply invisible to us. Photography was a technological advance that carried in its wake a huge enhancement in cognitive power by permitting us to re-represent the events of interest in the world in a format and at a rate that was tailor-made for our particular senses. Before there were cameras and high-speed film, there were plenty of observational and recording devices that permitted the scientist to extract data precisely from the world for subsequent analysis at his leisure. The exquisite diagrams and illustrations of several centuries of science are testimony to the power of these methods. But there is something special about a camera. It is stupid. In order to capture the data represented in its products, it does not have to understand its subject in the way a human artist or illustrator must. It thus passes along an unedited, uncontaminated, unbiased, but still re-represented version of reality to the faculties that are equipped to analyze and ultimately understand the phenomena. This mindless mapping of complex data into simpler, more natural, or user-friendly formats is, as we have seen, a hallmark of increasing intelligence. But along with the camera and the huge pile of still photographs that poured out of it came a resource problem. The photos themselves needed to be labeled. It does scant good to capture an event of interest in a still picture if you can't remember which of thousands of prints lying around the office is the one that represents the event of interest. This matching problem doesn't arise for simpler, more direct varieties of tracking, as we've seen. But the cost of solving it should often be borne. The trick can pay for itself, time is money, in cases in which it permits indirect tracking of important things that cannot be tracked directly. Think of the brilliant practice of sticking colored pins in a map to mark the location of each of a large number of events we are trying to understand. An epidemic may be diagnosed by seeing, thanks to color coding, that all the cases of one sort line up on the map alongside one or another inconspicuous or even heretofore undepicted feature, the water main, or the sewage system, or perhaps the route of the postman. A serial killer's secret base of operations may sometimes be homed in on, perhaps we could call it villain taxes, by plotting the geographic center of the cluster of his attacks. The dramatic improvements in all our kinds of investigations, from the foraging strategies of our hunter-gatherer days to the contemporary investigations by our police, poetry critics, and physicists, are due in the main to the explosive growth in our technologies of re-representation. We keep pointers and indices in our brains and leave as much of the actual data as we can in the external world, in our address books, libraries, notebooks, computers, and indeed in our circle of friends and associates. A human mind is not only not limited to the brain, but would be rather severely disabled if these external tools were removed, at least as disabled as the nearsighted are when their eyeglasses are taken away. The more data and devices you offload, the more dependent you become on these peripherals. Nevertheless, the more intimately familiar you become with the peripheral objects, thanks to your practice in manipulating them, the more confidently you can then do without them, sucking the problems back into your head and solving them in an imagination disciplined by its external practice. Can you alphabetize the words in this sentence in your head? Try it. Can you alphabetize the words in this sentence in your head? A particularly rich source of new techniques of re-representation is the habit that we, and only we, have developed of deliberately mapping our new problems onto our old problem-solving machinery. Consider, for instance, the many different methods we've developed for thinking about time by actually thinking about space. We have all sorts of conventional ways of mapping past, present, and future, before and after, sooner and later, differences that are virtually invisible in unrefined nature, onto left and right, up and down, clockwise and counterclockwise. Monday is to the left of Tuesday for most of us, while in a valuable convention that is fading from our culture, sad to say, 4 o'clock is tucked under 3 o'clock on the right-hand side of every day or night. Our spatialization of time doesn't stop there. In science particularly, it extends to graphs, which have by now become a familiar system of diagrams for almost all literate people. Think of the profits or the temperature or the loudness of your stereo rising up, up, up from left to right with the passage of time. We use our sense of space to see the passage of time, usually from left to right in standard convention, except in evolutionary diagrams in which earlier eras are often shown at the bottom with today at the top. As these examples show, our ability to imagine these diagrams when verbally invited to do so is itself a valuable Gregorian competence with many uses. Our ability to imagine these diagrams is parasitic on our ability to draw and see them, offloading them at least temporarily into the external world. Thanks to our prosthetically enhanced imaginations, we can formulate otherwise imponderable, unnoticeable metaphysical possibilities. Armed with these mind tools, we tend to forget that our ways of thinking about the world are not the only ways, and in particular are not prerequisites for engaging the world successfully. It probably seems obvious at first that since they are so manifestly intelligent, dogs and dolphins and bats must have concepts more or less like ours. But on reflection, it shouldn't seem obvious at all. Most of the questions we've raised from our evolutionary perspective about the ontology and epistemology of other creatures have not yet been answered, and the answers will no doubt be surprising. We have taken only the first step. We've seen some possibilities to be investigated that we overlooked before. Of all the mind tools we acquire in the course of furnishing our brains from the stockpiles of culture, none are more important, of course, than words, first spoken, then written. Words make us more intelligent by making cognition easier, in the same way, many times multiplied, that beacons and landmarks make navigation in the world easier for simple creatures. Navigation in the abstract, multidimensional world of ideas is simply impossible without a huge stock of movable, memorable landmarks that can be shared, criticized, recorded, and looked at from different perspectives. It's important to remember that speaking and writing are two entirely distinct innovations, separated by many hundreds of thousands and maybe millions of years, and that each has its own distinct set of powers. We tend to run the two phenomena together, especially when theorizing about the brain or mind. Most of what has been written about the possibilities of a language of thought as a medium of cognitive operations presupposes that we're thinking of a written language of thought, brain writing and mind reading, as I put it some years ago. We can get a better perspective on how the advent of language might magnify our cognitive powers if we concentrate instead on why and how a spoken language of thought, an offspring of our natural public language, might do some good work. Talking to ourselves. There is no step more uplifting, more explosive, more momentous in the history of mind design than the invention of language. When Homo sapiens became the beneficiary of this invention, the species stepped into a slingshot that has launched it far beyond all other earthly species in the power to look ahead and reflect. What is true of the species is just as true of the individual. No transition is more astronomically enabling in the life of an individual person than learning to speak. I must put the word learning in scare quotes, since we have come to realize, thanks to the work of linguists and psycholinguists, that human infants are genetically predesigned for language in many ways. As the father of modern linguistics, Noam Chomsky, often says, with excusable exaggeration, birds don't have to learn their feathers, and babies don't have to learn their language. Much of the hard work of designing a language user, or a feather user, was accomplished eons ago and is provided to the infant in the form of innate talents and dispositions, readily adapted to local conditions of vocabulary and grammar. Children acquire language at breathtaking speed, picking up new words at an average rate of a dozen a day for years on end, until they become adolescents when the rate slows to a trickle. They master all but the finest points of their grammar before they enter school. In addition to all their linguistic interactions with their family members and pets, babies and toddlers spend many hours vocalizing to themselves, first babbling, then indulging in marvelous mixtures of words and nonsense syllables richly endowed with different tones of voice, hortatory, soothing, explanatory, cajoling, and eventually evolving into elaborate self-commentary. Children enjoy talking to themselves. What might this be doing to their minds? I cannot answer that question yet, but I have some speculative suggestions for further research. Consider what happens early in the linguistic life of any child. "Hot," says mother, "don't touch the stove." At this point, the child doesn't have to know what hot or touch or stove means. These words are primarily just sounds, auditory event types that have a certain redolence, a certain familiarity, a certain echoing memorability to the child. They come to conjure up a situation type, stove approach and avoidance, which is not just a situation in which a specific prohibition is typically heard, but also a situation in which a mimicking auditory rehearsal is encountered. Crudely simplifying, let's suppose that the child acquires the habit of saying to itself aloud, "Hot, don't touch," without much of an idea what these words mean, voicing them merely as an associated part of the drill that goes with approaching and then avoiding the stove, and also as a sort of mantra which might be uttered at any other time. After all, children are taken with the habit of rehearsing words they have just heard, rehearsing them in and out of context, and building up recognition links and association paths between the auditory properties and concurrent sensory properties, internal states, and so forth. That's a rough sketch of the sort of process that must go on. This process could have the effect of initiating a habit of what we might call semi-understood self-commentary. The child, prompted initially by some insistent auditory associations provoked by its parents' admonitions, acquires the habit of adding a soundtrack to its activities, commenting on them. The actual utterances would consist at the outset of large measures of scribble, nonsense talk composed of word-like sounds, mixed with real words mouthed with much feeling but little or no appreciation of their meaning, and a few understood words. There would be mock exhortation, mock prohibition, mock praise, mock description, and all these would eventually mature into real exhortation, prohibition, praise, and description. But the habit of adding labels would thus be driven into place before the labels themselves were understood or even partially understood. I'm suggesting that it's such initially stupid practices, the mere mouthing of labels in circumstances appropriate and inappropriate, that could soon turn into the habit of representing one's own states and activities to oneself in a new way. As the child lays down more associations between the auditory and articulatory processes on the one hand, and patterns of concurrent activity on the other, this would create nodes of saliency in memory. A word can become familiar even without being understood, and it is these anchors of familiarity that could give a label an independent identity within the system. Without such independence, labels are invisible. For a word to serve as a useful, manipulable label in the refinement of the resources of a brain, it must be a ready enhancer of sought-for associations that are already to some extent laid down in the system. Beyond that, words can be arbitrary, and their arbitrariness is actually part of what makes them distinctive. There is little risk of failing to notice the presence of the label. It doesn't just blend into its surroundings like a dent in the corner of a shoebox. It wears the deliberateness of its creation on its sleeve. The habit of semi-understood self-commentary could, I'm suggesting, be the origin of the practice of deliberate labeling in words, or scribble words, or other private neologisms, which in turn could lead to a still more efficient practice, dropping all or most of the auditory and articulatory associations and just relying on the rest of the associations and association possibilities to do the anchoring. The child, I suggest, can abandon out-loud mouthings and create private, unvoiced neologisms as labels for features of its own activities. We can take a linguistic object as a found object, even if we have somehow blundered into making it ourselves rather than hearing it from someone else, and store it away for further consideration offline. Our ability to do this depends on our ability to re-identify or recognize such a label on different occasions, and this in turn depends on the label having some feature or features by which to remember it, some guise independent of its meaning. Once we have created labels and acquired the habit of attaching them to experienced circumstances, we have created a new class of objects that can themselves become the objects of all the pattern recognition machinery, association building machinery, and so forth. Like the scientists lingering retrospectively over an unhurried examination of the photographs they took in the heat of experimental battle, we can reflect on whatever patterns there are to be discerned in the various labeled exhibits we dredge out of memory. As we improve, our labels become ever more refined, more perspicuous, ever better articulated, and the point is finally reached when we approximate the near magical prowess we began with. The mere contemplation of a representation is sufficient to call to mind all the appropriate lessons. We have become understanders of the objects we have created. We might call these artifactual nodes in our memories, these pale shadows of articulated and heard words, concepts. A concept, then, is an internal label which may or may not include among its many associations the auditory and articulatory features of a word, public or private. But words, I am suggesting, are the prototypes or forebears of concepts. The first concepts one can manipulate, I am suggesting, are voiced concepts. And only concepts that can be manipulated can become objects of scrutiny for us in our minds. Our minds. Our minds. Our minds.